So I want you to use synthetic division and divide x cubed minus 1 by x minus 1. So don't forget, where are we going to put our zeros? So we'll put what in the box? The left box. 1. And then read the coefficients across. So it goes 1, 0, 0, negative 1. Wait, this should be positive 1, not negative 1.
Just 1, 1, 1.
1, 1, 1, 2.
Wait, why is the last one positive?
It should have been positive 1 when you're reading this. Wait,
No.
you're right. You're right.
So, no remainder?
So then 0. On the notes that I have from, I guess I changed it. So, no remainder. So the answer is yes, because there's no remainder.
Great use of that line.
I know. I just used a little too much space. So now evaluate f of 1. So what does that mean?
You plug in 1 for x.
I plug in 1 for x, and this is my f of x right here. So when I plug in 1 for x, I get 1 cubed minus 1, which equals what? 0. So what do you notice?
It's the same.
They're the same.
Oh, okay. So when you plug both the factor and the f of x.
So whenever you substitute your factor in for x, you're going to end up with the same answer. When you substitute the factor into f of x, it's the same answer.
So if the remainder were to be like 2,
Then you would get 2.
Okay.
Mm-hmm.
So it's not just for 0.
Right. So if this were plus 1 and then this were plus 1 and you had 2, then it would be 1 squared plus 1, which would be 2.
Okay.
So you end up getting the same.
Okay, so you get the same remainder if you plug it into f of x.
Mm-hmm.
So is it just coincidence that if we plug it into the factor, it also gets the same answer as the...
It's just a coincidence.
Okay, great.
Mhm.
Don't...
So that's essentially what the remainder theorem is. It's when you divide x minus c, so essentially the factor, into f of x, it's the same as f of c. So in our example we just did, dividing by x minus 1 was the same as evaluating f of 1. So essentially the c's are the same number.
What if you told us to divide by x plus 1?
It would be the same.
So we wouldn't be able, would we be able to use the remainder theorem?
You would have to do f of negative 1. So if I divided by x plus 1, the factor that goes here is negative 1, right?
Yes.
So then I would plug in f of negative 1
Okay.
and end up with the same answer.
Okay.
So no matter the sign, it's still going to work. It just depends on positive or negative what you plug in. Okay, so if x minus 1 is a factor, what do you know about the graph? Like, what does that tell us about what the graph looks like if it is a factor?
It's gonna be on. It's Courtney. It'd be this on x equals 1.
So when we've been like in 7.2 when we graphed,
Does it have S?
and all of them were in parentheses, those were the factors, right? So what did we do at that graph?
So it's going to have a 0 at x plus 1. I mean, at positive 1 on...
Yes, so that means that it would be an x-intercept at x equals 1. It's like, you know, in 7.2, 7.2b, we had these equations in factored form that were like this, something like that, we knew that there were zeros or x-intercepts at 1, -2, +3. That's the same thing as saying it's a factor of it. Just a different way to say it, but it means that they're x-intercepts. So find the remainder when doing division by x minus 3. So I want you to try synthetic division, f of x, x minus 3.
Oh, it's not your
Then I want you to evaluate f of 3. So basically I want you to prove this theorem correct. So try parts A and B.
And we're dividing up right now on the f of x.
So there's gonna be a 0, right?
You're gonna, oh, they're gonna be a 0? Yes, because there's no x. So you should get -4 for both. So what we've learned is using synthetic division or plugging in the factor to f of x gets you the same result. So we both know that the remainder is -4.
Wow.
Which step did you like better?
Synthetic.
Synthetic or where you evaluated?
Synthetic.
You like synthetic better than evaluating?
That was much easier than multiplying all of that out in your head.
So you can do whichever one you want, and they both will work out. If I said give me the entire function, like where I would be asking for like 2x² minus x minus 3 minus 4 over x minus 3, then you would have to do synthetic because I'd be asking for the whole long thing. But if I just said what's the remainder, then you could certainly do step B instead, and it would be up to you to decide whichever one you want. But there are certain times when synthetic might be easier. So like some of you said you liked synthetic better. There are some times where just plugging it in is easier. In this case, synthetic was a little bit easier just because if I didn't give you a calculator and I had you do this, it might be a little bit more difficult. So it's up to you. But it's cool to see that they both work out in the same way.
So why would we need the remainder?
When,
Is there a reason for
yeah, once we get to graphing, I'll show you. So determine whether x minus 1 is a factor of x to the 98th minus x to 70. So which one would I want to do here?
Synthetic.
You'd want to do synthetic here?
Yeah.
Yeah.
And you'd want to account for all of the zeros from 98
Most definitely.
all the way?
Of course.
I think
We have time.
Okay.
Wait. No, why don't
Courtney,
we
you
just
be
do the other
serious?
one?
No, Courtney.
Yeah.
Doing synthetic.
We're not
Like
doing-
long division?
Please.
Yeah.
No.
Long division, you still have to account for the zeros.
Oh, what?
No.
Wait, we're not looking for the remainder. We just
No,
Okay,
we just want to know if it's a factor or not.
Don't you just plug it in
So
your
you
calculator?
could just plug in 1 for each of those, and then if the remainder is 0, then
Exactly.
so it would be.
So this is an example where we wouldn't want to do synthetic division. We would just want to plug in f of, what number would I be plugging in? 1 or -1?
1.
1. So 1 to the 98th power is 1 minus 1 to the 72nd power, 1 plus 1 to the 45th minus 3. What do you get? -2, so not a factor. And to answer your question, Courtney, this would be like more of the type of question that you would see, like, is this a factor or not?
Okay. Yeah.
Wait, so
Maybe not necessarily needing the remainder, but
How do you know it's not a factor?
Because there's a
because this is the remainder. So if there's a remainder, that means it's not a factor.
So you did. You just skipped all the other ones, all the numbers in between.
So when you're plugging in, you can skip them. You don't have to account for the zeros. You're just plugging it in. If I did synthetic division, I would have to do 1 and then 0, 0, 0, 0, 0, 0, 0, all the way to 72, which is -1, 0, 0, 0, 0, 0, all the way to 45. And then you'd have to do all the way from 44 to 1. So you would need like 94, 95 zeros. That's why you wouldn't want to do synthetic division. So the other way is just evaluating the factor by plugging it in to the original. Does that make sense?
And every time you do that, you have to flip the sign.
I might want to do that.
No?
Instead of it being -1, it's just +1.
Oh, here? Yeah. You flip the sign.
I already know.
Okay, completely factor, given that x minus 1 is a factor. So what would I need to do here? I've got to do synthetic division. What number goes in the box? 1. Read across the coefficients. What would they be?
1, 4, 0,
1, 4, 0,
5. Negative.
and -5. Good. So, what's the completely factored form?
X squared plus 5x plus 5.
And what was already a factor?
X minus 1.
Good. So we tag that on at the end.
I do.
Yes. Because it says completely factor it. So you want it back to the original. And I can't factor this anymore, can I? The x squared plus 5x plus 5? No. So we leave it.
Are you kidding me?
Wait,
I hate
what?
technology.
Like you can't like.
You can't break this down any more than it already is.
So you can't do 5 and 1 with
Because they wouldn't add up to 5.
So you have to put that x minus 1 in the
Because if you leave that out, then it's not completely factored.
Okay. Yeah, because then it'd be 6x. Okay.
Okay, on the next example, I'm about to blow your mind.
Okay, please blow my mind.
It's really cool though. It's not bad.
I'm begging you.
I promise. It's actually really cool. So here it says that 2 of them are factors. So 4 is a factor and -2 is a factor. And we want to completely factor it. So if it gives me 2 of them, I'm going to actually do synthetic twice. So let's choose one of them to do first. Should we do 4 or -2? It doesn't matter.
4 because it's positive.
4. Okay, 4 because it's positive. Let's do it. So I'm going to put a 4 here. Make sure you leave a little bit of room. And let's read the coefficients across. What are they?
Ocho.
Negative 14, negative 71, negative 10,
Good. This gets a little large.
I am not doing that.
One's like this large on the test without a calculator.
You could.
I got it.
I'm just trying
It gets small again.
Yeah,
It gets small again.
You're welcome.
Okay.
I did it.
So here we are. We've done it once. Here's what's about to happen. I just want you to watch.
Are you serious?
We're doing it again.
What?
We're doing it again. Hi, Claire. So we just draw another box underneath, put the -2, bring the 8 down, and we start over.
I didn't leave myself enough space, dang it.
I told you to leave space. When will you learn?
Why is that? Oh, because this. Oh, that's nice. Oh. You don't have to. Okay.
Okay, so now I'm just going to write this whole thing completely factored. So we already have x minus 4, x plus 2, and what does this make? So now I've gone down 2 degrees because I've done synthetic twice. So it goes from x to the 4th. My final answer is 8x what? Squared plus 2x minus 3. Can I factor that?
I feel like you can.
You can. I'm gonna just tell you, you can.
You can.
I'm not kidding you.
You're lying. Oh.
When did y'all turn on me with the factoring? When did that happen? No.
Ever
it's-
since the day that I missed that factoring lesson, I've regretted running cross country. It was literally.
Why is it 8x squared instead of 8x cubed?
Because we did synthetic twice.
I cannot explain.
So the
that
first
way.
time it went to cube, the second time it went to squared.
Yeah, but dude, you don't understand. I was like, oh no, it'll be fun, it'll be fun. And to this day, I'm still not comfortable with it. Like, I never, think of the numbers. That I'm
Okay,
supposed
so
to
let's
put
do
there.
this factoring one together then. The last number is negative, so that means that my signs are going to be same or different.
Different.
So let's do plus and minus. Factors of 8. 4 and 2. Factors of 3. 3 and 1. So I don't really know which one goes where, so let's try 3 and then 1. Does that work?
4x minus. It's not 4x.
So outside is negative 4, inside is positive 6.
That's right.
So that is right. Nice. Final answer.
I used to be so good at factoring.
Okay, what I want you to do now is get your calculator, and I want you to graph this r of x right here. And you can just use the standard window.
Nope.
And here are my zeros. So I have zeros at negative 2, negative 0.75, which is the same as saying negative 3/4, right? 0.5, which is 1/2, and 4. My final answer was x plus 2, 4x plus 3, or 2x minus 1, and x minus 4, right? That was our answer. And so if I set each one of these equal to 0, then these would be my answers.
You'll get that.
So that's it.
Crazy. Yeah. Crazy.
Really? Oopsie.
You remember this moment that we had in our lives?
Yeah, I told you the day of the quiz.
Wait, didn't.
No, I had to teach 2 classes before the quiz. That's why I had no clue to do it.
You're
Bar
not
has
gonna
almost been
clue
open
what you were
3
doing on
months.
the day of the quiz, tell me.
Okay, because I just didn't feel like learning because I didn't have to teach it.
That was
Okay.
in November.
Didn't Dr. Russell said we weren't going to do any more teaching things? I mean,
Oh,
I'm
I
sure she's
kinda
forgot,
don't.
but
So I'm going to put 10 on the outside, read across 4, negative 25, negative 154, and 40. These numbers seem a little big,
But wait, there's
but they're not bad because it's by 10. Oh, wait, what am I doing? I said negative 15. I'm silly.
probably since they want us to find the zeros.
how many people have dropped out of this class?
I think I just figured out how to do this.
Maddie, Christian.
Could have sworn that.
So how do I read this across? How do I read this across? It would be 4x squared.
Plus 15x minus 4.
Good. And I can factor this because I need to find all the factors.
I hate you.
We can do it.
You can definitely factor that.
Okay, so then we have opposite signs.
It'd be 4 and 4.
Let's try
It's
maybe try 4 and 1.
4x
4 and 1, 4
minus
and 1.
1. X
4 times 4.
plus 4. Wait, you did 4. What?
Oh, I did. You're right.
It's
I'm
4x
silly.
plus 1.
4x plus 1.
No, minus.
4x minus 1.
No.
Plus 4. Yeah, no.
And then x plus 4. Because then you get positive 16 minus. Yeah, perfect. So then my other two zeros are what?
1/4 and negative 4.
1/4, negative 4, and then the other one that they gave me was 10. If I ask what the completely factored form of this equation would be, what would it be?
X minus 10, 4x minus 1, 1x plus 4. Right?
And then x minus 10, yes. So that if I asked for like the completely factored form, that's what that would be.
Oh, we're not done.
When you graphed it, you got x equals -2, right?
Yep.
Do you see any other ones? No. Okay. So but I don't need any other ones because I can do synthetic division, and then that brings me down to what? An x squared, and from there I can factor after that if I can. So I'm going to do synthetic division on that equation.
No, stop.
Well, you get x equals -2 as the 0, so you just put that straight in. That's okay.
So is this going to be -2?
Uh-huh.
Oh, shoot. You get a 0.
Okay, so here's where we are.
Oh, how did you get a 3? Don't answer that.
Now, how could I write that? It's an x squared equation, right? So we've got 1x squared plus 0x plus 3, right? But I don't really need that 0x in there because that's what something babies would do. So I just have x squared plus 3. Now what's the completely, I can't factor that anymore. So what's the completely factored form?
X plus 2, x squared plus 3.
Perfect.
So when we get our,
Oh, is it x plus 2 just from the -2?
Uh-huh.
when we get our, when they give us the factored form and then they tell us like to graph it, we don't really have the x squared inside the parentheses, do we?
No.
So, but this is okay for us to answer?
Yep.
Okay.
Now, if I took this a step further, and this is also going to be a good introduction as to why you only saw 1. When I set these parentheses equal to 0, you get x equals -2. What happens when I set x squared plus 3 equal to 0?
Don't you get like the square root of 3?
Well, you move the 3 over and you get x squared equals -3. When I take the square root of a negative number, what's that? Imaginary. So that means that you couldn't see it on your graph, but you actually have 2 other roots. And so we'll talk about that
Wait, like,
next
wasn't
class.
big enough, or, like,
No, you just couldn't see them. They're imaginary.
They don't exist.
But we don't have to write them.
No, we don't even. We're going to talk more about that next time. Just something fun. Now, 6c, can the function be factored in another way?
You do that method where you like
What's the method when you've got 4 terms?
pull out a number.
What do you do?
Quadratic.
Grouping.
This for here.
Oh no, are we going back to
Yeah, that's
factoring?
what I thought.
Try grouping it. See if you get the same thing.
Okay, wait, I think I may remember how to do this. Kind of. Not really. No.
Yeah. Yep.
Yes.
Yay.
So what do you pull out of the first 2?
X squared.
You're left with.
X plus 2.
Then what do you pull out of the second 2?
3.
You're left with.
X plus 2.
So my final answer is x squared plus 3, x plus 2. So you could have done grouping.
Yeah, why don't we just do that?
Because it doesn't always work, Tommy. Just sometimes.
Why?